Hello everyone, my name is Nidhi Singh, Professor Gyan Vihar School of Pharmacy, that is a part of Suresh Gyan Vihar Chapter. So today we are going to discuss this aliphatic amines. Last lecture related to this aliphatic amines. So this aliphatic amines and the protein that it comes in the pharmaceutical chemistry first, and in this we have already discussed about topic that is given at the PCS syllabus. So today we are going to discuss about what are the identification method of enzymes, what are the structures and uses of organic compounds related to amines, and also the students are going to know about that what are the test method of amines, and they are about structure and uses of compound related to amines such as ethanol. So here the students are going to know about that the test methods which are related to this amine and which are related to this amine. And in this, the students are going to know that what is your amine and how what is your amines and how they are going to distinguish between the primary, secondary, and the tertiary amines. That what are the tests that are related to this primary, secondary, and tertiary amines, and they are also going to know about the following compound, that is the ethylamine, hydrogen, and vitamin. What are the structures and what are the uses? And these ethylamine, diamines, these are the compounds. They are having this amine ring in amine structure. These are having the amine function group in these structures. And here the students will, if they are getting a sample in the lab to distinguish between the amines, that what is it, the primary amine or the secondary amine or the tertiary amine, then we can easily separate that sample, and we can tell that this is a primary, this is secondary, and this is tertiary amine. So these are the today we are going to discuss some of the tests that are related to the amines. Let's start the topic. So the first is a test for amines. In this is your Hinsberg test, and this Hinsberg test is for the primary, secondary, and the tertiary amines. So in the Hinsberg test, um, this test is used to distinguish for the primary, secondary, and the tertiary amines. So the principle of this test is the treatment of an amine with benzene sulfonide chloride in aqueous sodium hydroxide is useful for determining whether an unknown amine is primary, secondary, or tertiary. So here we are going to treat our amine with the sulfonide chloride in aqueous sodium hydroxide um, for determining the unknown amine, whether this unknown amine is the primary, secondary, or the tertiary amine. So here also the amine will react with this benzene sulfonide chloride that is in the aqueous sodium hydroxide, that is present in the aqueous sodium hydroxide, and after that this reaction we can distinguish the primary, secondary, and the tertiary amine. So this means the test is for this the separation for the differentiation that tells about the differentiation between this primary, secondary, and the tertiary amines. So in this primary amines react with benzene sulfonyl chloride A to give sulfonamides B, which have an acidic amide hydrogen that react with sodium hydroxide to form the sodium salt of the sulfonamides, and the C that is soluble in the aqueous sodium hydroxide solution. When the acidification of the solution takes gives the this acidification of the solution gives a precipitate of the sulfonamide B. So here, this is the first reaction that is showing that the primary amine. So in this, the primary amine is reacted with this benzene sulfonyl chloride, and here this benzene sulfonyl chloride, this is your A, that is your benzene sulfonyl compound chloride, and it is present in the acidic. This benzene, this sulfonamide, this is the B sulfonamide. So this primary amine is reacting with this benzene sulfonyl chloride A, and it is giving the B, that is a acidic amide hydrogen, that is having an acidic amide hydrogen, means the hydrogen that is attached to this nitrogen, that is an acidic hydrogen. And when we are treating it with NaOH, then they are forming a salt of N-sulfonamide C. So here they are forming a salt of N-sulfonamide C, and the C is aqueous. C is soluble, and the C is soluble in the aqueous sodium hydroxide solution, and acidification, here acidification of the solution gives a precipitates of the sulfonamide B. So here the primary amine, here you can see that this is your primary amine, and this primary amine, when it is treated with this sulfona, the benzene sulfonyl chloride, this is your benzene, this is your sulfonyl, and this is your chloride. So this A is your benzene sulfonyl chloride, and in this, if they both are reacted, you can see this chlorine is removing from here, and this nitrogen which is having an this nitrogen which is having an which is this nitrogen which is having an electron, this unshared pair of electrons, they are getting attached or bonded to this sulfur, and there is a formation of this sulfonamide. Sulfonamide is formed here. So in this sulfonamide, there is this hydrogen is present here, and this hydrogen um, this hydrogen is an acidic amide hydrogen. This is an acidic hydrogen, and this acidic hydrogen is then removing here by the reaction with this NaOH. So here it is reacting with this NaOH, and after that this NaOH is dissociated into Na positive and OH negative. After that, here the H positive will move out from here, and this N will get a negative charge. And if the N is getting a negative charge, this H is having the positive charge. So this H, which is having the positive charge, this will react with this OH negative, and there is a formation of water molecule from here, and this N will get reacted, then N is having the negative charge, and this N negative charge will react with this sodium. So there is a formation of this salt. This salt is formed here. The sodium salt is formed here. Sodium salt of sulfonamide is formed after the reaction of this sulfonamide with this NaOH, and this salt is soluble. This salt is soluble, but this salt is the C. The salt is soluble in the aqueous sodium hydroxide solution, and the acidification. If we are doing here the acidification of this solution, then it is giving a precipitate. It is giving a precipitate, that is a B. This HCl, then this HCl is dissociated into your H positive and Cl negative, and this CH positive and Cl negative. This H positive will then react with this N negative, and there is a formation of this compound, and then Cl will react with this Na. So there is a insoluble precipitates are formed in case of your this primary amine. So in this, in the test for amines, the first test is your Hinsberg test. So the Hinsberg test is used to distinguish between the primary, secondary, and the tertiary amines, and there and or you can say that the Hinsberg test is used to differentiate between the amines that is your primary, secondary, and the tertiary. And the principle of this Hillsborough test is that if we are treating the amine with your benzene sulfonyl chloride in aqueous sodium hydroxide, if we are treating our amine with the benzene sulfonyl chloride in aqueous sodium hydroxide, then it is useful for determining whether an unknown amine is primary, secondary, or tertiary. Means if we are getting a sample for the student, if we are getting a sample in the lab that we have to differentiate between, we have to tell that what sample it is. Is it primary or is it secondary or is it tertiary amine? So which amine is this? So in that case, we are doing this. We are performing a test. This Hinsberg test we are performing, and the principle of this Hinsberg test is that there we need this benzene sulfonyl chloride, sodium hydroxide, and the HCl. So in this case, we are treating this. We are treating this amine, the sample with the benzene sulfonyl chloride in aqueous sodium hydroxide. Then after that we can determine whether this unknown sample, unknown amine is your primary, secondary, or tertiary amine. So in the primary amine, and we are reacting this primary amine with the benzene sulfonyl chloride A, and here we are getting a B sulfonamide after treating this primary amine with the benzene sulfonamide after treating the amine with the benzene sulfonyl chloride. So here you can see that N is having a lone pair and the Cl from this benzene sulfonyl chloride is removed from here after taking the electrons from the sulfur. So the sulfur is getting the positive charge and the Cl is getting the negative charge. Then this RCH2, it will react with this this H from the amine will remove out from there, and this lone pair will getting attached to this this sulfur, and there is a formation of a bond. That is, there is a formation of this sulfonamide, that is a B, and the Cl is removed out, and from that amine the H is removed out. So there is a formation of a bond. So HCl is formed here. So here HCl is formed here, and there is also sulfonamide is formed. So in this, the sulfonamide and the HCl is formed in this case. After that, the sulfonamide, when we are treating it with the acidic amide hydrogen, then it is reacting acidic amide hydrogen, which have an acidic amide hydrogen, then it reacts with the sodium hydroxide. So after that, it is reacting, the sulfonamide is reacting with the NaOH. So this NaOH, from this the NaOH will dissociate into Na positive and OH negative. So the H, that is your acidic hydrogen, to the acidic amide hydrogen, this acidic amide hydrogen will remove out from here, and then the nitrogen will get the negative charge on it, and after that this H positive will react with the OH negative, and there is a formation of uh, water, and this will get removed from here. And then after that there is a Na positive that will react with the negative. So there is a formation of the soluble salt, that is your sodium salt of sulfonamide. This soluble salt of sulfonamide is soluble in the aqueous sodium hydroxide solution. And after that, if we are acidifying, if we are doing the acidification, if we are doing the acidification of this soluble salt of sodium, salt of this sodium salt of sulfonamide, then there is the acidification with the HCl, and in this you can see the HCl will dissociate into H positive and Cl negative, and the H positive and the Cl negative, then H positive will react with the negative nitrogen, and this Cl will react with the sodium positive. So after that, there is a formation of a insoluble. It will give the precipitates which are insoluble of the sulfonamide B. So there is a formation of the insoluble precipitates of the B. Next is your or now, if we are treating with the secondary amine, so if we are treating with the this amine with the secondary amine, then here you can see that there are if the secondary amine is reacting with this benzene sulfonide chloride, there is a formation of a sulfonide amide D that does not contain an acidic amine amide hydrogen and thus is not soluble in the aqueous sodium hydroxide solution, and acidification of this mixture does not dissolve the insoluble sulfonamide. So in the secondary amine, in the primary amine, we have done the reaction with the benzene sulfonide chloride and there is a formation of insoluble after the acidification. But before the acidification, there is a soluble precipitate forming there. But after the acidification of this mixture, then there is a formation of insoluble precipitates are forming with the acidification with HCl. But in case of your secondary amine, this when this secondary amine is reacting with this benzene sulfonyl chloride, then from this there is a formation of an insoluble precipitate because it is not containing any acidic hydrogen. This is not containing any acidic hydrogen which can react with this NaOH. So that is why they are forming. It is forming here insoluble precipitate. After that insoluble precipitates, we are doing here acidification of the insoluble precipitates, and there that does not dissolve the insoluble. This acidification of the mixture. This acidification of the mixture does not dissolve the insoluble sulfonamide. So here, if we are doing the acidification of the mixture, that is the insoluble precipitate, there is no solubility. There is a formation of this insoluble precipitate. So here also insoluble precipitates are formed in secondary amine. In first step also they are forming an insoluble. They are insoluble to the sodium hydroxide solution, and in the second step also they are forming an insoluble precipitate. So in the first step, this insoluble precipitate is formed due to the presence due to there is no hydrogen present in this insoluble precipitate. So here you can see in the reaction, this nitrogen which is having a lone pair, this is getting attached to this this benzene sulfonide chloride, and here this hydrogen will remove out from the amine, and this chlorine will remove out from this benzene sulfonyl chloride, and this will get attached to this position. So S is getting the positive, N is getting the negative, and they will form a bond. After that, there is the formation of the sulfonamide. So in this case, there is a formation of this sulfonamide is formed here, but this sulfonamide, it is not having any hydrogen, acidic hydrogen is present in this sulfonamide. So here this sulfonamide is soluble, and this is not soluble in the active sodium hydroxide solution. First, it is not soluble in the active sodium hydroxide solution, and insoluble um, this insoluble aqueous, this thus it is not soluble in the sodium hydroxide solution because there is no hydrogen that is present on this nitrogen. So after that, again, this insoluble precipitate, that is a sulfonamide, that insoluble precipitate are then acidified, and from here there is a formation of insoluble precipitate because there is no hydrogen which get there is no sodium which get related which get reacted with this so here which reacted with this HCl, and the formation of this insoluble sulfonamide is formed. But in case of the primary amines, firstly in the first step there is a formation of the soluble precipitate. After the acidification, there is a formation of the insoluble precipitate. But in the secondary amine, there is in the first step only there is a formation of this insoluble precipitate is formed there. And then there is after the acidification also this insoluble precipitate does not solubilize, but it it remain as it is insoluble precipitate. So this is a secondary amine in which we have reacted with benzene sulfonide compound, and there is a formation of a sulfonide B that does not contain an acidic amide hydrogen, and thus is not soluble in the aqueous sodium hydroxide solution, and the acidification of the mixture does not dissolve the insoluble sulfonamide. In this is your secondary amine, and in this H is removed out from here, and here from here this Cl is removed out from. So this H and Cl will form a bond, that is your HCl, and here it will get the negative charge, and this S is getting the positive charge. So there is a formation of bond, and there is a formation of this sulfonamide is formed. The sulfonamide is formed, and it does not dissolve in this NaOH solution because it is not containing a acidic hydrogen that is present or attached with this nitrogen, and there is a formation of this insoluble precipitates. After that, this insoluble precipitates are reacted, these insoluble precipitates are reacted with this HCl. So this HCl, from this HCl, this there is an acidification with this HCl, and there is a formation of this insoluble sulfonamide. So here the insoluble sulfonamide is formed. So in the case of tertiary amine, now what happens in the tertiary amine is the tertiary amine react with this Hinsberg test, Hinsberg reagent. So here the tertiary amines do not react with benzene sulfonide chloride. However, the sodium hydroxide eventually will react with sulfonide chloride, and there is a formation of a salt that is your benzene benzene sulfonic acid, that is your E. So this E, that is your benzene sulfonic acid, E, that the amine does not dissolve unless it is a low molecular weight with water soluble amine. In the initial reaction mixture will dissolve on acidification with HCl, since a water soluble amine hydrochloride salt F is formed. So in case of the um, tertiary amine, this tertiary amine do not react with this benzene sulfonide chloride. This tertiary amine do not react with this benzene sulfonide chloride, and this benzene sulfonide chloride, the because it is not having any hydrogen present on this tertiary amine. So here the sodium chloride, that the sodium hydroxide, will react with this benzene, benzene sulfonide chloride, and there is a formation of this benzene sulfonic acid is formed here. So here the salt of benzene sulfonic acid is formed, because here there is no formation of the sulfonamide, because this tertiary amine will not react with this sulfonamide. So there is no formation of this sulfonamide. So the sodium hydroxide reacts with this benzene sulfonamide, sulfonic acid, and there is a formation of this salt of the benzene sulfonic acid. So after that, the formation of this benzene sulfonic acid, it is there is acidification is there, and after this acidification, this will dissolve on acidification with HCl, and a water soluble amine hydrochloride salt is formed. Water soluble amine hydrochloride salt is formed here. So the tertiary amine, in case of tertiary amine, you can see here this tertiary amine is not reacting with this benzene sulfonide chloride, and in this the benzene sulfonide chloride is reacting with this NaOH, and from here the Cl is removed out, and the Cl is removed out from here, and this NaOH is reacting with this sulfur. Sorry, this sulfur. So this NaO will react with this S, and this H and Cl will react with each other, and there is a removal of this HCl from here. So this is a salt of benzene sulfonyl chloride is formed, and you can see here this tertiary amine is as it is here. So it is forming an insoluble. It is forming an insoluble. So the amine does not dissolve in the initial reaction mixture. In the first step, it is not mixture. It is not forming any soluble precipitate, but soluble form. It is not in a soluble form. But after the acidification, after there is a acidification of this amine, we are reacting with this acidification, we are reacting with this HCl. There is a formation of this soluble amine hydrochloride salt is formed here. So in the tertiary, in the case of your tertiary, in this Ginsberg test, this is used for differentiating the benzene, this amine, unknown amine, whether this is the primary, secondary, or tertiary amine. So here in the primary, you have seen that in the first step, there is a formation of a soluble salt is formed here. But after reacting with the HCl, there is a formation of the insoluble precipitate. But in case of your secondary amine. In case of a secondary amine, if it is reacting with the benzene sulfonide chloride, then there is a formation of the insoluble precipitate in the first step. And after that, if we are doing acidification of this in the with this HCl, then there is a formation of this insoluble sulfonamide is formed. Next, in the tertiary amine, in case of the tertiary amine, these are not reacting with the benzene sulfonide chloride, and these are not reacting with the benzene sulfonide chloride. And here the sodium hydroxide and benzene sulfonide chloride are reacting with each other, and there is a formation of a salt or benzene sulfonide acid plus your amine is formed there. So amine, after that, in the initial step, it does not react, it does not form a soluble, it is not soluble, but after that, it is soluble in the acidification with the HCl. And if they are forming there is a formation of a water soluble amine hydrochloride salt is formed here. So here the hydrochloride salt is formed. So here to summarize of Ginsberg test in the primary amine, when we are adding a primary amine to the Ginsberg test solution, there is a clear solution, which on acidification, there is a clear solution which on acidification with HCl would form a precipitate. So in case of primary amine, there is a formation of a precipitate is formed after the acidification with the HCl. But in the first step, the primary amine, when the primary amine is added to the Ginsberg test solution, then it is forming a clear solution. So here it is forming a clear solution with your Ginsberg test, and after the clear solution is then reacted, the clear solution is then reacted with the HCl, there is acidification in this, then there is a formation of a proper precipitate is formed here. Next, in the secondary amine reaction, there is a reaction to form a suspension of an insoluble solid or oil which does not dissolve on acidification with HCl. But in case of HCl, in case of secondary amine, you can see in the first step in the if they are reacting, adding a secondary amine to the Ginsberg reagent or the test solution, then there is a formation of a suspension of an insoluble solids or oil in that suspension. And after that, if we are doing the acidification with the HCl, then there is a then also that insoluble solid or oil does not dissolve with the acidification with the HCl. Next is your tertiary amine. So in the case of a tertiary amine, in the tertiary amine also it does not react with the benzene sulfonide chloride in the Ginsberg test solution, and this tertiary amine is not reacting with this benzene sulfonide chloride in the Ginsberg test solution. So it is forming and initially provides an insoluble solid or oil, an unreacted amine. So in this case, this tertiary amine is providing a reacting, it is forming a unreacting amine. So in this case, it is reacting and it is forming a unreacted amine is formed here. And in this case, the unreacted amine is then acidified with the HCl, and there is a formation of a clear solution of the amine salt. So here there is a formation of a clear solution of amine salt. So from this Ginsburg test, we can differentiate easily this primary, secondary, and the tertiary amine. We can easily separate these amines, that is your primary, secondary, and the tertiary. So the next test is this is your Ginsburg test. The next test is your nitrous acid test. So in the nitrous acid says the primary amine react with nitrous acid and it gives nitrogen gas. And the secondary amine react with nitrous acid to give yellow oily nitrous amine. And in the case of tertiary amine, when it is reacting with the nitrous acid, there is a formation of a soluble nitrite salt. So here in the primary amine, when it is reacting with the nitrous acid, here nitrogen gas is evolved out. So R NH2HONO, we can write the nitrous acid like this also. And after that, there is a reaction between this. R of this NH2, R OH will react with each other. Then there is a formation of this H2O, and this N will react, and there is a evolution evolve of this nitrogen gas. But in case of the secondary amine, there is a reaction of this nitrous acid, then there is a formation of a yellow oily nitrosamine. So this is your nitrosamine. This is your nitrosamine. In this case, this R2 N will form a bond with this NO. And plus H2O will form what two molecules evolved out. So in case of a tertiary amine, so in the case of a tertiary amine, the tertiary amine is reacting with this nitrous acid, and there is a formation of a soluble nitrite salt, that is your R3N. This is a tertiary amine, and when it is reacting with this nitrous acid, then there is a formation of this amine is formed here. This is a, and after that there is a formation of this trialkyl ammonium nitrite is formed here. So here my alkyl ammonium nitrite is formed here, and in this case there is a formation of soluble nitrite salt is formed here. So here the soluble nitrite salt, this soluble nitrite salt is formed here in case of your tertiary amine. So here from this nitrous acid test also we can differentiate this primary, secondary, and the tertiary. So in the primary, the nitrogen gas is evolved out, and in the secondary, this yellow oily nitrosamine is formed here. And in the second tertiary, there is a formation of a soluble nitric salt is formed. Next is your principle. So in this, the nitrous acid is a source of electrophilic nitrosodium ion which react with amine, and the nitrous acid being unstable is related in situ from a mineral acid and sodium nitrite. So in the primary aromatic amine, these are reacting with this nitrous acid, and there is a formation of a diazonium salt that is stable but low temperature. So on reaction with phenol, an aromatic diazonium salt undergoes a coupling reaction, and there is a formation of a di. So on reaction with this phenol, there is a formation of this diazonium salt which undergoes a coupling reaction, and there is a formation of a di. So this ArNH2Cl, that is your phenol, that is your NaNO2 plus HCl. This is reacting at 4.85 degree centigrade, and there is a formation of this ArN2Cl, that is a diazonium salt, and this N plus NaCl is formed as H2O. After this, this diazonium salt is reacting with this phenol, and there is a formation of a di. So here in this case, the primary aromatic amine is reacting with the nitrous acid, that is your NO2 plus HCl at a low temperature. This is a low temperature, 4.85 degrees centigrade. And after that, on reaction with phenol, there is a coupling reaction is occurring. nitrous. So here you can see this is a coupling reaction which is occurring and they are forming a dye. This is the formation of diazonium salt, and this again there is a coupling reaction is happening and there is a formation of a dye is forming. So this is your nitrous acid test. So in this primary aliphatic amines are forming diazonium salt which are unstable and liberate nitrogen to form a carbonium ion, which is aqueous reaction medium, and that form an alcohol or an proton elimination gives an alkene. And this alkene, here you can see this is your primary amine, primary aliphatic amine, and when it is reacting with this high nitrous acid, there is a formation of an alcohol plus or alkene is formed, and your nitrogen gas is water. In the primary aliphatic amines forms diazonium salts which are unstable and it liberates nitrogen and there is a formation of a carbonium ion. So this R is having a positive charge which is forming a carbonium ion which in aqueous reaction medium forming alcohol or on proton elimination given alkene. So in the aqueous reaction medium, it is forming this carbonium ion is forming the alcohol, and in the and when there is a proton elimination from it, then there is a formation of this alkene because nitrogen gas is got out, the liberation of this nitrogen gas. So primary amine liberate nitrogen with nitrous acid, unlike secondary and the tertiary amine. So this can be used to distinguish primary amine from the secondary and the tertiary amine. So here this primary amine, in the case of primary amine, there is a liberation of nitrogen gas with nitrous acid. Unlike secondary, in the case of secondary and tertiary, it does not. So this can be used to distinguish primary amine from the secondary and the tertiary. And the secondary amine, both aliphatic and aromatic on reaction with nitrous acid give yellow colored oil and nitrosamine, which unlike amines are insoluble in active mineral acid, and this is used as a salt test for tertiary or secondary amine. So this secondary amine, both aliphatic and aromatic on reaction with nitrous acid, it gives yellow colored oil and nitrosamine that is unlike amine and that is insoluble in aqueous mineral acid, and it is used as a test for secondary amine. So here R2NH plus NaNO2 plus HCl, there is a formation of this and NaCl plus H2. So here there is so in the aliphatic tertiary amine that are forming a water soluble salt with nitrous acid. So here there is a reaction given, and in the aromatic tertiary amine on reaction with nitrous acid undergoes electrophilic substitution with nitrosonium ion at the para position of the phenyl. So here you can see that this is your tertiary aromatic tertiary amine when it is reacting with the nitrous acid and it plus HCl. It is undergoing a reaction and there is it is undergoing an electrophilic substitution reaction, and after that there is a formation of this nitrosonium. There is a formation of this. On this phenyl nitrosonium electron electrically substitution with nitrosonium ion at the P position. So this nitrosonium ion is attached to the P position of this phenyl group, and there is a formation of this NaCl plus H. Next is the structural uses of these compounds, so organic compounds that are related to this amine. So in this ethanolamine. So in this ethanolamine, that is also known as your aminoethanol, monoethanolamine, ETA or MEA is an organic chemical compound with the formula HO, CH2, CH2, NH2, and the molecule is both a primary amine and a primary alcohol due to the hydroxyl group. So here in the structure you can see it is having a hydroxyl group that is attached to this CH2, and this shows that it is a primary alcohol also and it is a primary amine also. So this ethanolamine, which is having the two three names also, the two amino ethanol, monoethanolamine, ETA, or MPA. It is an organic compound which is having the formula, chemical formula OHOCH2, CH2, NH2. And the molecule, as you can see that this molecule is both a primary amine as well as a primary alcohol, because primary alcohol is also attached to it. So the preferred IUPAC name. So the preferred IUPAC name is amino ethane 1 all, and the other name is your 2 amino ethanol, 2 amino 1 ethanol, beta amino ethanol, beta hydroxyethyl amine, and glycosinol. So the chemical formula is C2H7NO, and the molecular mass is 6.61.08 gram per mole. And the appearance of this ethanolamine is viscous, colorless liquid. The appearance of this ethanolamine is viscous, colorless liquid, and odor is your unpleasant ammonia-like odor. And the density of this is 1.0417 gram per centimeter cube. And the boiling point of this ethanolamine is 170 degrees centigrade, and the solubility in water is miscible. That this ethanolamine is soluble in water. Next, the application of this ethanolamine. So it is used as feedstock in the production of detergent, emulsifier, polishes, pharmaceutical corrosion inhibitor, chemical intermediate. So the application of this ethanolamine is that it is used as a feedstock in the production of detergents, emulsifiers, polishes, pharmaceutical corrosion inhibitors, chemical intermediates, and it is also used as a pH regulator in cosmetics. So this is the application of this ethanamine, that it is also used as a pH regulator in the cosmetics, and the ethanamine is often used for alkalinization of water in steam cycles of power plants, including nuclear power plants with pressurized water reactors. Ethanamine oleate is used to treat uh, esophageal varices, that is a condition in which an abnormal dilated blood vessel inside the tissue lining the esophagus or upper part of the stomach. As here in the picture, you can see the esophageal varices. It is an abnormal enlarged vein in the tube that is connected to the mouth, throat, and the stomach, and or you can see the esophagus. And this condition occurs most often in people with liver or diseases, with serious liver diseases, and in their symptoms is your vomiting, black carry, or bloody stool, or loss of consciousness. So this is the condition, and in this ethylamine oleate is used to treat this disease. So next is your ethylene diamine. So ethylene diamine, it is your abbreviated as ethanolamine, is the organic compound with the formula that is a H4NH2 whole twice, and it is widely used building blocks in chemical synthesis. And ethylamine diamine readily reacts with moisture in humid air, and it produces a corrosive, toxic, and irritating mist to which even short exposure can cause serious damage to health. And this is the first member of the polyethylene amine. So the preferred IUPAC name is your ethane 1,2-diamine. Other name is egamine 1,2-diaminoethane. So here you can see the two amine groups are attached to it. The chemical formula of this is C2H8N2, and the molecular mass is 60.10 gram per mole. And appearance is colorless liquid, odor is ammonia-like odor, and the density is 0.90 gram per centimeter cube. And the boiling point is 116 degrees centigrade, and the solubility in water. So it is most miscible in water. Next is the uses of this ethanamine. So the applications of this ethylene diamine is that ethylene diamine is a prominent derivative of ethylene diamine, is a chelating agent EGBTA. And the ethylene diamine is an ingredient in the common bronchodilator drug aminosilane, which where it serves to solubilize the active ingredient farming. And the ethylene, the amine has also been used in dermatologic preparation, and it is also used as urinary acidifier. And this ethylene diamine used for the synthesis of first generation antihistamine drug, and the ethylene diamine, because it contains two amine groups, is a widely used precursor to various polymer condensate dyes from formaldehyde are plasticizers. It is widely used in the production of polyurethane fibers, and it is also used as corrosion inhibitors in paints and coolants. Next is the amphetamine. So amphetamine is a potent central nervous system stimulant that is used in the treatment of attention deficient hyperactivity disorder, necroplasty, and obesity. And the amphetamine was discovered in 1887 and used as two instruments, that is the levoamphetamine and the dextroamphetamine. In this, the dextroamphetamine, this is the structure of dextroamphetamine, and that is the levoamphetamine. And this, the preferred IUPAC name, one phenyl propane and the other name is alpha methylamine. So this is the structure of your amphetamine. The chemical formula is C9H13N and the molecular mass is 135.20 grams per mole. And the appearance is your colorless volatile liquid with an amine order. And the order is your characteristic strong with the amine order, and the density is 0.90 gram per centimeter cube. And the boiling point is 200 degrees Celsius or 203 degrees centigrade, and it is also slightly soluble in water. And the uses of this is that amphetamine is used to treat ADHD, that is attention deficient hyperactivity syndrome, and the narcolepsy, the sleep disorder, and obesity. It is used by some athletes for its physiological and athletic performance enhancing effects such as increased endurance and alertness. At therapeutic dose, amphetamine causes emotional and cognitive effects such as before-year change in desire for sex. Next is the obesity. Obesity is a condition in which a person has accumulated so much body fat that it might have a negative impact on their health. It is linked to a number of health complications, some of which are life-threatening, type 2 diabetes, and the heart disease, high blood pressure, certain cancer, and these strong gallbladder diseases, fatty liver diseases, high cholesterol, sleep apnea, and other breathing problems, arthritis, infertility, and in the necrophilaxy is a condition is a neurological disorder characterized by the brain with inability to control sleep, wakefulness cycles, and the symptoms of this necrophilaxy is your excessive daytime sleepiness and the sleep paralysis hallucination. So the questions, the tertiary amine cannot form hydrogen bonding because they are or do not have hydrogen. The reduction of nitrogen nickel will produce Hoffman bromide reaction is used to convert your primary amide to primary amine, and methanol has a high boiling point than methylamine because hydrogen bonding is stronger in methanol than in methylamine. Amines which are bonded in one alkyl group are primary amines. So aniline reacts with phenol in presence of zinc chloride at 200 degrees centigrade to form a secondary amine. So these are the references for this topic, and this aliphatic amine is completed. And thank you so much for today's lecture.